In the fourth and final part of this video on object concepts, we discuss two important class relationships, composition and aggregation, and then examine an example that illustrates a composition relationship. We begin by explaining what characterizes each of these kind of relationships, explaining how they are similar and how they are different. Both kinds of relationships are has-a relationships, in contrast with inheritance relationships that are characterized by the is-a predicate. In both cases, the component object is an instance variable in the composite class. The relationship exists between the component class and the composite class. The key difference between composition and aggregation is that with composition, the ownership is exclusive. That means the component object cannot be a component of any other class at the same time. Consider the following relationship. A car has an engine. In that case, we would have a car class that has an object of class engine as one of its instance variables. Because each engine can only belong to one car at a time, it is a composition relationship. By contrast, in an aggregation relationship, the aggregated or component object may belong to multiple aggregating or composite objects. Consider the relationship a course has students. In this case, the course class would likely have an array of student objects as an instance variable, because a student can take more than one course at a time. The ownership is not exclusive, so this is an aggregation relationship. Next, we examine the UML diagram of the program that we will examine next, which shows how composition relationships are depicted in UML diagrams. In this example, the customer class will contain two account instance variables. Specifically, one customer has two accounts. The solid diamond is placed at the component end of the line connecting the two classes. The numbers 1 and 2 on each side represent one customer and two accounts respectively. An asterisk is used when the number of component objects can vary. In this relationship, if this relationship had been an aggregation relationship, it would have been symbolized by using a hollow diamond. The dotted line with the open arrowhead that connects the customer main class to the customer class symbolizes a uses relationship. The customer main class uses the customer class. Such relationships often indicate that a method is the method in a using class has a local variable whose type is the class being used. Furthermore, the method would normally call the methods of the class that it uses. So now let's examine the code associated with that UML diagram, beginning with the customer class. Notice that this class has two instance variables of type account. This is the composition relationship. A customer has two accounts. The constructor, like most constructors, initializes each of its instance variables using the supplied parameter that corresponds to it. Because the parameter names shadow the instance variable names, the reserved word "this" is needed in each assignment. The only other method in this class is the display method. As is so often the case in composition classes, the display method of the composite class calls the display method of the component classes. To have a complete program, we need the customer main class that contains a main method. Notice that the main method contains a local variable whose type is the class customer. It calls the constructor of the customer class, supplying it with the customer name and his two accounts. We call the display method to output the customer object. So now, let's run the program. Notice that the output includes the balance of both accounts, which comes from the display method of the account class. We conclude this video with a brief discussion of two important principles of good object-oriented design. The first of these is the concept of cohesion, which is a measure of the degree to which the components of a class belong together. Specifically, in a class that is highly cohesive, all of the instance methods should access at least one of the instance variables, or in the case of a private method, be called by one of the public methods. The second concept is that of coupling. Classes are coupled by composition, aggregation, and other relationships. The number of other classes a given class is coupled with is a measure of its coupling. In good object-oriented design, one strives to maximize cohesion but minimize coupling. These same principles apply to software design prior to the introduction of object orientation. Previously, the goal was to maximize the cohesiveness of functions and minimize the coupling between them. With object-oriented design, these principles apply at the class level.